everyone. Today we are going to see DT based activity video on topic called Spirometer demonstration. So this particular video is going to carried out by students from 3rd year BME. So here we will be seeing a spirometry device and its functionality and what are the different functions which is being carried out during the test with the help of spirometer. So let's start this activity video. Hi students, shall we start this experiment?
Yes.
So what is the name of this experiment? What we are going to see today?
Respiratory parameter measurement using spirometer.
Yes, fine. So before we begin with this experiment, first tell me what is the importance of studying this experiment? Why we need this spirometer device?
So spirometer is basically an instrument which is used to measure the lung volume and capacities. So it will help us to check how well the lung is functioning, and it is used to check some respiratory diseases like obstructive and restrictive diseases, asthma, etc.
Okay, yes. Okay, now let me ask you another way. We have so many traditional spirometer, right? And in what way this particular spirometer is uniqueness compared to the other spirometer that is which we used as a traditional one?
So currently there are some traditional spirometers, but they have some drawbacks like comfortness, affordability, and accuracy in the data. So we have a computerized version of spirometer, so it overcomes all the drawbacks of the traditional spirometer.
Yes, according to you, what could be the empathy perspective of this particular experiment? What is the outcome you can get by using this experiment? How will it will support the patient?
So the traditional spirometer is based on a mechanical system, so it has many limitations like affordability and accuracy in the data. So computerized version improves all these. They don't have to visit an hospital to take a test. It can be taken very easily, and since it is a computerized version, it will give accurate data, thus helping the patients to recognize what disease they are having.
And also treatment will be given in a proper way. So in that way also we can give better treatment for the patient. So it is going to be the empathy perspective of using this computerized spirometer. So let's start this spirometer experiment now. So what is the software which is coming inbuilt with this particular device?
So the software we have used today is RMS Helios. So when we enter, we have many options like new patients. So while we click new patients, we have to enter our personal details like patient name, age and weight. So it is used to analyze our breathing test, whether it is obstructive or restrictive or normal. So we have tests like FVC. So FVC is a forced vital capacity, and FVC is the slow vital capacity, and MVC is the maximum voluntary ventilation.
So now we will see FVC, that is forced vital capacity. What is the main functionality of this FVC?
So FVC is used to find the lung volume.
So can we demonstrate this FVC test now?
I see. So you click on FVC. So the patient is made to sit relaxed, and we have to use this nose pin. So FVC, the patient has to blow out very hard and fast as possible, so that then she should inhale all of this running. Okay, we can complete the test. So this is the result of the test we have taken. So above this axis is the expiration, and below this is the inspiration. And we have FEV1, so it is the forced vital capacity as the first second.
So these are the two graphs. Here we will plot a volume based flow. Here this one is time based volume. So here we have 3 points. One is that is forced expiratory flow 25%. Another one is 50%. This is one is 75%. So simultaneously we will get this graph. So here we can have points like the FEV1, that is forced expiratory volume at first second. So this one is for second. Similarly we have till 6th second. So this particular parameter is very important when we are measuring the CPOD disorders, so that we can see in interpret option. So after taking test, if you click the interpret option, where you can easily see whether the patient is having what type of disorder. So if you see this matrix, you have option of obstructive type, mixed type and restive type disorder, and if the person is normal, you can see the normal case here. So this is the formula, that is FEV1 divided by FEC. This is used to identify the person is having CPOD or not. So these parameters or values we can get from this the previous test, where you can see the formula, that is the point FE1 under FEC. So after putting or substituting all the values in this formula, once you get the value less than 70% means, then it is considered to be the CPOD. If it is above 70% means the person is normal case. So in this way only this particular algorithm will work on, and it will plot randomly, and then easily we can witness whether person is in what type of state, whether it is normal or mild or restrictive type or the combination of both, that is mixed type.
So for the test we have taken now, we have got the result between restrictive and normal type.
So it is in borderline. So in future the person may get the problem with restrictive type.
So we can make the analysis in this.
Here we have option trends, individual test.
So trends will be like graph plots, and we can see like what is the value of FVC and what is the value of FEF at 75% and FEF at 25%.
And so as CPOD, if you want to find CPOD, you need to substitute in the formula. So for that you need numerical values. You can get the numerical values in the options of trends. Directly you can get what is the point at FE1 and FE2.
And in analysis we have another called individual test. We can see what are the results for our individual test. We will take a set of tests like 2-3 times to get the accurate results. So we can see each values for each thing. So now we have taken a single test, so we have only one test values here.
So parallelly you can see all the parameters and its numerical values. You can later on check it for further calculation or some other analysis. So I think you might have understand this spirometer experiment to some extent. Hope so you like this video. Thank you.